So, uh, very happy to meet you, my students. And here I'm going to talk about single channel formulas. Okay. So already I told you that there are two models. One is single channel model. The another one is a multi-channel model. Look at the picture here. Here the server is only one server. Okay. But the queue may be different. But look at this. Only one server is there in this particular queuing situation. As such a situation, we call it like a single channel model or single channel we say. So in this single channel, first we will discuss about the formula, and in the another video we would be discussing about how to solve the problem. Okay, right, look at this single channel problem here. First we have to calculate what is the arrival rate. So lambda is called arrival rate, and then service rate also we have to find out mu. Okay, so arrival rate means what? The number of pupils arriving per unit time. That's called what? Arrival rate. Service rate means number of person can be serviced in 1 minute by the service personnel. Okay, take for example here, this person can serve how many people per minute. That's called service rate. So all the formula, look at this, all these formulas are based on this lambda and mu only. Lambda and mu only. Am I correct? Lambda mu, and lambda mu, and every formulas are based on lambda and mu. So these two things we have to find out from the given data. That is very important thing. Arrival rate and service rate. Now this is what is called the expected or average or mean number of elements in the queue per unit time. Okay, so what is the expected number, or what is the average number, or what is the mean of the elements in the queue per unit time? That's called different way it is asked: average, expected, mean, or length of the queue, or queue length, like that. Different name it is used. So that is nothing but LQ. So LQ equals lambda square, that is arrival rate square, divided by service rate into service rate minus arrival rate. Okay, from this particular explanation we are getting this. So to find the queue length, that is number of people in the queue per unit time, we are using this formula LQ, queue length. Formula lambda square divided by mu into mu minus lambda. Next one is in the system. Okay, I told you what is the system, what is the queue. Am I correct? Look at this particular picture. These two people only called a queue. When you add this person also, it is called a system. I told you already. Am I correct? If you are taking this person under service also, it is called a queue. If you don't take this person, only waiting persons you are taking, that's called queue. So what is the expected or average or mean number of elements in the system? In the system, that is including the service personnel, is given by the formula LS, length in the system, equals lambda divided by mu minus lambda. Lambda divided by mu minus lambda. Okay, I will do the problem. When I do the problem, then it would be very easy for you to understand. Okay, right. Next one is the expected mean time in the queue. That is waiting time in the queue, given by the notation WQ. WQ means waiting time in the queue. That is on an average a single person, how long he has to wait to get his works serviced. That's called waiting time. So waiting time of a person in the queue is given by the formula WQ equals lambda divided by mu into mu minus lambda. Okay, so lambda is available from here, mu is available from here. Substitute all those in this particular formula, then we can get the waiting time of a person in the queue. Now what about the waiting person in the system? The waiting person in the system is given by the formula 1 divided by service rate minus arrival rate. Service rate minus arrival rate is called the waiting time of a person. The system means what? The person and the service also included with these particular persons who are waiting for the service. Next formula is about busy time of the server. Look at this. This is a busy time of the server. How long is working? Suppose the company is working 5 hours. Out of 5 hours, how many hours he is working? That's called busy time of the server. Or traffic intensity, we say. Traffic intensity, we say. It's given by the notation rho. So rho equals lambda by mu. Rho equals lambda by mu, where lambda is the arrival rate and mu is the service rate. If you substitute this in this formula, that is, if you divide the arrival rate by service rate, what you are getting is called the intensity or traffic intensity or busy time of the server. Like that, by different way it is called. Ideal time means the time in which the server is not working, called ideal time. Okay, so definitely ideal time would be equal to 1 minus rho, where rho is what? The busy time. So 1 minus lambda by mu. Sometimes this formula also very important. Okay, probability that the queue length exceeds n. Probability that what is the chance? What is the fraction that the queue length exceeds the number of person is n, is given by the formula p of greater than or equal to n is equal to lambda by mu to the power n. The probability that the queue length exceeds number of person n is given by this particular formula. So these are some of the discussions that I am making on this single channel system and connected to the formula. Okay, so in the next class I would be taking a problem in the single channel system, and you will understand clearly what I explaining to you. Okay, thank you.